Hi students, today we are going to solve two more problems in electricity. The seventh sum. How much charge flows through a 220 volt and 1500 watt heater in 1 minute? So first, what are all the given quantities? What are all given? Let us write. So the voltage V is equal to 220 volt. Power P is equal to 1500 watt, and the time is 1 minute. So 1 minute is equal to 60 seconds. These are all given. Now first of all, power P is equal to, power P is equal to voltage into current. This implies current is equal to power by voltage. So this basic equation you must remember. So we are going to substitute for power is equal to 1500. Therefore, current I is equal to power by voltage. So this is 1500 divided by 220. So this is equal to 150 divided by 22. Again, if you divide this by 2 means it is 75 divided by 11. 75 divided by 11 will be equal to, I will check it in the calculator and tell you, okay? So this is 75 by 11. 75 divided by 11. So this is coming as a 6.8. So I is equal to 6.8 ampere. But what is asked in the question, how much charge flows in 1 minute? Is it not charge? What is the relationship between current, charge and time? We have defined current is defined as the rate of flow of electric charges. So I is equal to Q by T. Okay. So I is equal to the quantity of charge Q divided by T. This implies Q is equal to I into T. So what is Q equal to? This 6.8. Okay, 6.8 multiplied by time is 60 seconds. So this is equal to 68 into 6. 68 into 6. So I am going to multiply 68 by 6. I get the value 408. 408, and the unit is coulomb. Okay, this is the answer. So this problem seems to be very simple, provided you have to remember the formulae. Two formulae we have used. Okay children, now the 8th sum. It is very important for your board examination also. Two bulbs which are rated 100 watt and 220 volt, and the second bulb 200 watt at 220 volt. They are connected in parallel. Understand? Parallel to a 220 volt line. So what total current is drawn by them? So two types of bulbs are given. What is the power of the first bulb is 100 watt. And the power of the second bulb is 200 watt. Is it not? So, what is the current flowing through them? Say for example, now I will take, this is bulb 1. Okay, this is bulb 1 and another, this is bulb 2. So, these two are connected in parallel. So this is 220 volt mains, understand? So this is 220 volt mains. V is equal to 220 volt. Normally we don't show a battery here because this is alternating current, AC voltage. So I am showing here only the two dots terminals. Okay. So if the main current is I supplied by the line, then this will be dividing as I1 and I2. So that the total current I is equal to what? I1 plus I2. And the voltage across both the bulbs will be the same because they are in parallel. Understand? So now for the first bulb, for the first bulb. So power P1 is equal to voltage V into I1, or I1 is equal to P1 divided by V. So what is the power P1 for the first bulb is 100 watt. So this is 100 divided by 220. So I1 is now equal to 10 divided by 22 ampere. You can take it as I1. Okay. Similarly, for the second bulb. So for the second bulb, P2 is equal to voltage V into I2. Therefore, I2 is equal to what? P2 divided by V. So the power of the second bulb is given as what? 200 watt. So this is 200 divided by 220. So current I2 is now equal to 20 by 22 ampere. What is the total current we have written already equal to in parallel combination? The total current I is split into two parts, I1 and I2. So if you add I1 and I2, we get the total current. So I is now equal to 10 by 22, okay, 10 by 22 plus 20 by 22. So this is equal to 30 divided by 22, that is equal to 15 divided by 11. Understand? 15 divided by 11. So if you divide this, means the answer will be 1.36, I think so. So 15 divided by 11 is equal to 1.36. Therefore I is now equal to 1.36 ampere. Is it not? So you have to verify this with your calculator. I hope you must have understood these two simple problems. Fine.